Hello, Algebra 2. We're going to be talking about something new today, something called sequences and series. Now, I know it's been a long time since we started something new. We have been doing radical equations for the past 2 weeks or so. And with that being said, we're practically done with that topic, and we're not going to go back to it for a foreseeable future. A couple things that I want you to keep in mind is that originally we planned to be back at school today when we started doing the remote learning. However, because of the situation now, as you already know, the um, you know President Trump has extended the social distancing for about 2 more weeks from April 15th. So most likely we're going to be having school off schedule and continue to do remote learning until May. And you guys all know that NJSLA is completely canceled for this year. So that means that our uh, traditional way of relearning the standards and those kind of things in order for you guys to get prepared for NJSLA, well, those are all out of the question. Your SGOs, your practice tests, and those will all not be there. So it's going to be less rigorous for us. I think that means it's really good news for most of us. However, I'm still going to upload a lot of videos and I'm going to make you guys still learn different topics of Algebra 2 so that you guys will still have a Algebra 2 curriculum, you know, like just folded, completely over with by the time you guys enter your junior year next year. Okay, so just please keep that in mind. Today we're going to be mostly talking about the sequences, and series is something else entirely different. But whenever you guys hear of sequences, I want you guys to think of just an ordering of numbers. Okay, order of numbers, or if you guys think of sequences, it's just sequence of numbers. When we say it like that, then there's a number in order. There's a number that we have something. There's usually what we call a pattern to it. Okay, and I'll show you what that means. But the very, very first sequence that you guys have all dealt with, you guys have actually learned it when you guys were, I don't know, kindergarten, preschool. The very first sequence that we all learned was 1, 2, 3, 4, 5, 6, 7, etc. That is basically the first sequence that we have ever encountered with in our lives. And so let's do these questions here. Oh, no, this is something different. There is going to be two different types of sequences that I want you to remember. There's one called arithmetic sequence, and the other thing is called the geometric sequence. Okay. Now, arithmetic sequence, if you take a look here, is a set of numbers in a particular order. Well, that's the definition of a sequence, right? An arithmetic sequence, each term is determined by adding a constant. That's it. So whenever you think of arithmetic, it starts with A. Think of add. Whatever that you're consistently adding to the previous term, well, that's called a common difference. So, for example, if you take a look at this sequence of numbers here, we have 3, 6, 9, 12, 15, just like that game that we used to play, this 3, 6, 9 game. This right here, and then it's going to go to 18, 21, 24, etc. This is called a sequence of numbers. This right here, the common difference, as what we would like to call it, is basically what you're adding every single time consistently to reach the next number in the list, in the sequence. Okay? So it's basically a list of numbers, and how we find that out, what the formula is, well, that's determined by what we call a common difference. Okay? So let's try some of these examples here. We're going to be only be determining, which means that you can only tell me yes or no situation. Determine whether each sequence is arithmetic. So 5, -6, -17, -28. Is that an arithmetic sequence? Well, how do we figure that? Well, if it's an arithmetic sequence, that means that there needs to be something called a common difference, right? Is common difference consistent? So to go from 5 to -6, to go from -6 to -17, what do you have to add? Okay? Now, the easiest way to figure that out is take the higher end of the number, and then you will subtract the lower end of the number. So the one that's right next to it, to the left of it. -6 minus 5, when you subtract those two, it actually ends up being -11, right? Which means my common difference, we will start with D, it actually ends up being -11. So 5, you subtract 11, you get -6. You subtract 11, you get -17. You subtract 11, you get -28. So it's consistent. So which means as long as the common difference holds true, then I say yes, that's definitely a arithmetic sequence. Next, determine whether each sequence is arithmetic. For this one, I do 12 minus 4. 12 minus negative 4 actually, and what I get is 16. So from negative 4 to 12 to 28 to 42, if I keep on adding 16, do I get the arithmetic sequence or not? Well, negative 4 plus 16, we've already established how that is already 12, right? 12 plus 16 is 28. What about 28 plus 16? 28 plus 16, if you type that in your calculator or do it otherwise, you actually end up with a 44. So which means this 42 is inconsistent with this arithmetic sequence formula or the common difference. Therefore, this is not arithmetic sequence because the common difference does not hold true. That's how you determine whether it's arithmetic sequence or not. Okay. Now, for guided practice, I would like you to pause the video for now, and then I would like you to try this on your own, and just play it back again once you have the answers ready. Oh, that's 7, by the way. Okay, assuming that you guys have the answers for me now, you're going to find out if the common difference holds true. So I always take the first two and I subtract them. 12 minus 7 ends up being a 5. So if I keep on keep consistently adding a 5, do I get the next number? Well, that's the question you guys have to just do. So 7 plus 5 is indeed 12. So 7, 12, that's 7 plus, you just have to add 5. But when you add 5 to 12, you get 17. It's not consistent because they say it's 16. So we say no. It's not an arithmetic sequence. For this one, we do 3 minus negative 6. Like I said, the second one minus the first one should give you the common difference. It becomes a 9. Negative 6, 3, 12, 21. I keep on adding 9. And do I get the numbers in the list? Well, surely it turns out 3 plus 9 is 12. 12 plus 9 is 21. And then I'm sure the next number will be 30. And it's going to continue. So this is absolutely a yes situation. Okay? So that's what arithmetic sequence is all about. Okay, so for the next question, find the next 4 terms of the sequence. Find the next 4 terms of the arithmetic sequence. Now these questions are going to be just a little bit more. This is going to be just a little bit more different because they're asking you to find the next 4 terms. We have the list of numbers here: 18, 14, and 10, and that's definitely a arithmetic sequence because what your common difference is that it's negative 4. Whenever you guys are doing these questions, you guys always must be able to identify for me what common difference is going to be. You can just simply take the second number minus the first number, and you will always get that common difference. Now, to find the next 4 terms of the sequence, all I got to do is just keep subtracting 4s, right? So 6, 2, negative 2, negative 6, and then I'm done. Okay? Now, I would like you to try this question on your own. Pause the video and let me know when you have it. Okay, so now since you have it, let's go over this. Find the next 4 terms. Again, what's my common difference here? Well, I have 18 to 11, so I'm going to do second term minus the first term gives me a negative 7. So 18, 11, 4, 2, 3, 4. I'm going to keep on subtracting 7s from the previous term. So that's negative 3, negative 10, negative 17, and negative 24. That will be the next 4 terms in the arithmetic sequence. Okay. So as of now, I'm going to stop the video, and I'm going to give you guys the independent practice here. So I'm going to give you guys this also on the Google Classroom. You guys need to determine these 8 questions. Determine each sequence is arithmetic, right? Yes or no. And please, you have to tell me why. Okay. To do these problems, you need to show your work. And so how do I show your work on arithmetic sequence? Well, first of all, number 1, find the common difference. D, you can use the letter D. And 2, prove how the sequence is arithmetic by using D. So for example, let's say that in the previous questions that we have done here, I have used the common difference and I have proved it literally by subtracting all the 11s from the previous terms, and I got those corresponding numbers that exactly shown as the question. That's how I could say yes. So for these questions here, I would like you to do the same way. Find the next four terms of the sequence. Again, you gotta tell me what the common difference is going to be. Without the common difference, I do not want you guys to be able to do these problems. I need you to tell me what it is first, and then tell me those next four terms by consistently adding that or subtracting that number. Okay. All right. Tomorrow we're gonna go over the geometric sequences and sequences, and then this week most likely I'm gonna give you one more assessment on just the sequence itself, and that's going to be your final grade for the marking period. I know I have been very slow with the grading, and I do apologize for that. I'll make sure that your grade is not going to be all suddenly changed at the end of Thursday because we still have until Sunday to wrap this up. So please be patient with me in those regards, and take care of yourself, please. And I'll upload another video for you guys tomorrow. Okay? Have a good day.